Hi, everybody. I'm Mr. Garwilek here, and I'm about to talk about some science. And I know how much you love to talk landforms and hear about all the neat things that are going on, but we're going to talk science today. And in particular, we're going to talk about slope. If you take a look at what's inside here, you can make some observations about what I've put together for you in terms of slope. You also might see that this thing is about to break apart because of the cracks there. But anyway,
I've been letting this dry for, a week since our last experiment that we had, where it's all muddy and slushy and gross, and let it dry.
And so what I'm going to do, hi Luna, so what I'm going to do
is I'm going to put something up here that allows you to see the water running down the
slope. Let's see how that works. If you remember from my last video, I had a trusty dusty here level. It has the little
bubble in the middle of that level that you have to have between the two lines so that you know things are level. And then this one obviously isn't level because it needs to, the bubble would go that way. Anyway, this isn't a commercial about how to use a level or a show about how to use a level. This is all about, I'm just using this because it has a hole in the middle here where if I want to be able to have my cup full of water, I can poke some holes, let it leak, and then I will watch the water go down the hill.
It's always good to have water.
Good pure water.
You can see the shiny in the window, and I'm trying to block the sun with my big head to make sure that you all can see everything okay. So I'm going to ask you, do you want me to use blue drops of water or blue drops in the water? Green or yellow? You'll have to think about that. Blue, green, or yellow. I'll let you think about that a little bit as I talk about and review some of the things we've been working on with landforms. How do scientists develop and use geographical models to explain how different systems work? How are landforms created and changed through slow and rapid processes? Today you'll probably see a pretty rapid process. You may see change within seconds, within minutes. That doesn't happen in the real world, though. Change happens over decades, over centuries, over millennia, But before we get started, I have to ask you a pretty simple question. Where can you find an ocean with no water? Where can I find an ocean with no water?
Greta, do you know where I can find an ocean with no water? Oh, I don't know. I barely have teeth. That's Greta, everybody, and Greg right next to her, G and G. But anyway,
where do you find one? On a map. On a map. What kind of rocks are never underwater? Do you know what kind of rocks are never underwater? Dry ones. And why are some fish at the bottom of the ocean? Why are they at the bottom of the ocean? Because they dropped out of school.
What I am going to do before we get going is poke holes in our cup. I'm just using a little screwdriver, nothing fancy, and you can see the hole that I'm poking. Because I want to make kind of a slower process. By the way, that's a horrible sound that I just did. You want to hear it? Hold on. That's an awful sound. That's like chalk on a chalkboard, if you even know what chalk is anymore these days.
But anyway, so I'm going to put this up here. Thank you for your votes. You all voted for a mixture of blue and yellow. Blue and yellow. So what I'm going to do is put in a couple drops of blue. Right here. I don't know why somebody voted for yellow. Hold on, I know why they voted for yellow. Pollution. Here's yellow. Ooh, that yellow went right down to the bottom. Look at how the blue is hanging around the top. Yellow went straight to the bottom. That's weird. What does that tell you? And look at how the blue is suspended in the air, like right in the middle. It's kind of suspended. It's not really dropping or going anywhere. But like I said, yellow went straight to the bottom. Okay, any good teacher would put the cap on and shake this up, but I'm not a very good teacher, so I think I'm just going to leave this like this and let it naturally. Well, I'll put the cap on because I don't want to spill it on my computer.
But I'm going to let it naturally settle while I talk about it a little bit more, and then we'll take a look. See, like right now, I'm going to show you this, so in a couple minutes you can take a look and see what's happened with our bottle. Okay? All right. So we were talking a lot about landforms and things. We've talked about deltas. We've talked about canyons. There's been so much that we've covered so far. We've talked about mountains, isthmuses, and other big words. So
what I would like to emphasize today is that water, when it hits these things, from the air, rain, not like somebody, spraying a hose out there or a pressure washer. But when water hits that stuff, water will land wherever it's convenient. I mean, it lands at a high spot, but it's always going to travel to the lowest point, okay, to that lowest place. And it may collect there until maybe it's gone up too high and it spills over, and then it finds a new low spot. That's what water does. It finds low spots. So,
in fact, I am ready. Remember how before it looked blue and green on top and the yellow went straight to the bottom? Look at. Ooh. Ah. Isn't that amazing? Okay. Now it's time for me to put some... Boy, that sun is tough on you. I'm sorry. I'm going to put some earth creatures. I'm going to put some figures out on our landscape. Of course, we have a soldier. I'll just put the soldier down below. I'll show you in a little bit how I did this. We're going to put I don't remember which character this is. Is this Mulan or is this something from the Muppets? Anyway, I don't know who this is. I was looking for candy, but I didn't see any candy. I'm going to put this in here, see what happens with that. I have a claw. If you'll notice this claw, I'm going to put this on the hill, okay? That'll go on the hill. I also have a Lego piece here that looks like, almost like a fire hose end or something like that. I'm going to put this also on the hill. And then I have this tubing. It's just Lego stuff. I'm going to put this on the hill and see what happens.
So if you're ready, here we go. Wasn't that a pleasant sound? Okay, notice where the water's going here and how it's draining.
Instead of it soaking up the sides, it's literally running straight down the hill. It's running down the slope of our hill. This isn't as scientific as I would like it to be, because we would normally be in class doing this together. I think I'm also going to make a small adjustment to my cup. Oh, you can see the drips coming out of the bottom? There, I put it exactly in the same spot. Time for more water. Alright, I filled that puppy up. I filled that up really good. So let's see what happens. Give you more of a bird's eye look. Are you noticing the start of like a river? If you look at a mountain range, you might notice areas where water flows down the mountain and actually carves out the mountain and gives it its shape. Yeah, I noticed that too, Mr. G. Oh, thanks, Greta. Greta's involved with this, and Greg's just kind of pouting. I don't know what his deal is.
But if you'll notice, we now have the start of a river coming right down. You can see it splitting the black little claw thing and our fire hose looking thing, Lego piece. I just put that stuff out there so it'd help you have some perspective as to what we're dealing with. This is pretty interesting though, kinda. And look at how things are filling up in our lake. The army dude almost has water up to over his boots. And we still have a good amount of water in that cup, but we're losing it. We are losing it. How do you get a pen across some water? By rowing? I don't know. What do you call it when a guy throws his laptop into the ocean? Adele, rolling in the deep. Who carries out operations underwater? A sturgeon. And I think I've told this joke before. If H2O is water, what is H2O for? It's for swimming and drinking, of course.
Anyway, cheesy jokes. But right now, this drip is creating its own mini delta in that it's dropping water down deep to create a little crater underneath, and then it's starting to push that sand up and over, and then any moisture that's in that sand goes right down in that little rivulet stream into our swampy pond.
Pretty interesting. So that is the excitement. We talked about our slope. You'll notice the water didn't go over here. The water didn't go over here. It is dry as a bone, and it's still like scratchy and hard and all that. But in here, everything is what they say, and I hate this word, but it's moist. I can't stand that word. Anyway, it's moist, like a family meal with, anyway, more words I don't like. But in here, if you can see, that hole is starting to deepen. And then the water flows through the claw, between the claw and the fire hose, Lego fire hose. I still have some more water. I might try to put the rest of it in if you want to watch. Okay. There we go. Drip, drip, drip. Isn't this exciting? It's like watching paint dry. All right, so some of the things we need to be aware of, that water is all around us. And when you have water all around you, whether it's a lake or whether it's a river or creek or ocean, that water is always kind of settling in that low point. And water is also going to move things. It pushes things out of its way. It soaks things, and it can change the land form, the shape of the land around it. Like what we have over here. It's soaking that land while the edges out here and over here are still hard as a rock. So this area, because it's getting soaked or saturated, it's able to be shaped by Mother Nature herself, or the Dixie cup of water. So water has a major ability to shape our land and to make our land something that is unique and ever-changing. So our land might look different in 1,000,000 years than it does right now today. Okay? Well, I want to thank you for watching. This is a little bit longer than I was hoping. I'm going to edit it down to make sure it's something that's hopefully easier to watch and something fun to watch. I want to thank you thank Greta and Greg for helping out and all of the cheesy jokes that you sent in. By the way, Shelby and Mohammed and Jason and Stella and all you great fifth graders out there that were sending in jokes, Rowan and others. Thank you. Keep sending them in. You can email me or put them in the comments. I'll see you next time.
Happy landforms.